Hey everyone. I'll just jump right in. That's good. I'm Rick Anderson, and we got the first part is machine learning for the time constraint educator. That's like there's we're jumping into a whole bunch of technology. We're jumping into what is machine learning, and kind of like at the very end of this whole process, we've now do we have sound? Uh-oh. On closed captioning. Okay, here you. Okay, sorry. All right. So yeah. So this is the thing: is that as humans, we're busy. As educators, I think we're also super busy. And the idea is we don't have a lot of time to figure all this stuff out. And ChatGPT is this outcome of a whole bunch of research and work. And it's also not the only thing out there. It's just the only thing that's been super meteoric rise, right? Growing faster than Facebook. It actually has more queries than Bing at the moment. So I mean, we're talking like there's an output that's valuable to people, right? But what is this? What kind of world are we jumping into? All this kind of stuff. So I've put together like this is the what I would like everything to do. So this is kind of both my kind of take on the situation and all of these things. But let me think here. Oh yeah, so before I jump on like my take, right? I'm Rick Anderson, and I'm moving things around. I'm sure. Let me put these out of the way. So anyways, my deal with Miro is I lock things in place. Funny. Okay, let's get back. All right, so I am Rick Anderson. I'm director of virtual worlds, and I'm also director of game research and immersive design, sort of known as GRID. We're part of teaching and learning with technology, and basically, I've been doing game technology, online learning since like 2005. I'm even like 25 years ago. I actually helped build the IT department that sort of runs continuing education. I've been a lot of firsts. I built some of the first websites at Rutgers University, as well as was it getting like working with the first groups of people working with say Second Life way back when, building up virtual worlds, and then game technologies, and then doing drop-in virtual worlds, and engaging this technology typically years before. Oh, neato! I got my share options set wrong for some reason. People can pull things. Darn it. Okay, let me focus. Okay, so yeah. So anyway, I'm this director of virtual worlds, and that's where I built all those virtual worlds, and they're drop-in. They're really cool. But I had to learn about the shape of learning. An object that might be hostile architecture in one environment is can be virtually more accessible. So a spiral staircase in real life is terrible, but a spiral staircase in a game helps you go up to a specific place without falling off or having to navigate the difficulties of stairs. So we have these things that are in two different states. So I get to explore that, and I get to explore that with all of my groups. So I'm going to talk about my groups. Uh, Before I forget, too, it's also I'm co-founder of Fair Use Building and Research Labs, which is one of the first maker spaces in New Jersey, and that's like 12 years ago. And again, these are all things that I brought in experience for. So I've built autonomous cars. That was about 10 years ago project. I've worked with robots of all kinds. So I did virtual games, realistic games. And then when I started working with autonomous cars, that began the journey into machine learning. So basically, machine learning has taken center stage, but I want to talk a little bit game research, immersive design. We came from virtual worlds and maker spaces and games, and now the machine learning is this new sort of like glue behind the scenes. And I'll get into what all of that means. So then the next portion is that we at Grid create games that are violence against women and children and victim protection, violence prevention and victim protection type games. So we put things where it's like we have really difficult topics, they mean a lot, and we have to develop empathy and help people get used to working with those emotions and how to deal with difficult situations in a robust way, and we use game tech for that. Then we also do augmented reality. So we do arbor trails, we do social justice. I run a course called Social Engagement Using Extended Reality, and we take on like Colonel Nelson, We are doing all of these different elements for, let's see, frame two. So we should be looking at frame two there. Um, and so essentially, we do these different technologies. So heavy tech, uh, both emotional learning and meaning are the things that we go for. Bringing meaning to the history of the campus, social justice, to the space, the physical space of the world using virtual technology. So anyway, we get to do lots of neat things with that tech. So I'm going to move over talking about the other part is I partner with people around the university. And so when I partner with people, I've got Carmela Scala, who's from the Italian department, and we've been working for almost 5 years. So Carmela Scala, we did Camille culturally and emotionally aware um, machine learning based on intelligent language acquisition with experiential learning. So we're building a whole dynamic environment for like learning languages, and we're using machine learning for that. So this is one of those things that's like finally come mainstream. So we're able to use everything from like emoji training to sort of automatically create sessions where you're trying to say what are the words in Italian that represent these things and do warm-up exercises, but then be able to use machine learning to generate more of them. Then with Jim Samuel, I'm working on machine and Carmela machine translation and sentiment analysis. So when you translate words using the large language models, what does the sentiment, does the emotion remain after the translation? And then the other one is with Jim, and that was we're doing equivocality with ChatGPT. So one of the things is you can say generate 5 sentences with two meanings to something like ChatGPT, and you can get like the chicken is ready to eat, and you can have two different meanings for that. And it's like how does these things decide when things are um, what is it when things what is it what how does it make decisions about what state if a chicken is ready to eat, it could mean that the chicken is fully cooked ready to be consumed, or it could also be the chicken is prepared to eat something else. So these are equivocality statements, and this is one of those things in machine learning. It's like part of like even gender studies. You say give me a bio of a nurse and it gives you a woman or a man. There are different reasons for that to happen, but it's a moment of like we don't know the answer to that question, and it has to be those two things. So these are kind of a really important areas to study, especially when it comes to large language models. So anyway, I'm really happy with the partners that I'm working with. We're getting to dig into some interesting problems, and what I want to do, with that is that we're trying to get into the meat of the material, trying to find out like where are the edges. So that's this portion. The other part about things like the new technologies, ChatGPTs that have come along, is that it's a major productivity boost. I've done at least like 15 new projects in a weekend or in a short period of time due to the fact that I can use ChatGPT to generate code. So I've generated things that do like role playing games and do the character generation and the dice rolling, and the entire ChatGPT thing can manage that. I also done things like FAQ managers, bots, in-game chat NPCs. So there's the technology is way more flexible than a lot of people think of it. It's just language only. We have a lot of stuff going in there. So the enabling factor, we're getting like a weird productivity boost. So so I will go back to the weird and the productivity boost. So there's also some framing that's important to do. So I want to kind of jump into this idea. I mentioned the Uncanny Valley, and I want to talk about that a little bit because we're kind of like visually we're familiar like with Uncanny Valley type things in terms of computer generation. So I'm going to talk a little bit about that for a moment. So one of the interesting beginnings for the Uncanny Valley idea is it's a Freud and the interpreter Dr. Jentz both like ended up having different statements that influenced how we perceive the idea of the Uncanny Valley. So I just wanted to mention this because there is something going on here. Because we'll just let me look at the quote. The uncanny is a class of terrifying which leads back to something long known to us, once very familiar. So language has been very familiar for us, and it's sort of definitely uncanny in the sense that we have these machines that are telling us about ourselves or technology or words. It's like essentially if I did animations, that's one thing, but now the words and our words have power. So we have something in that space. The other thing is the other person, Jens, believes that particular favorable condition for awakening uncanny sensations is created when the intellectual uncertainty whether an object is alive or not, and when an inanimate object becomes too much like an animate one. So these are ideas that are, say, written down. A machine learning thing would have to read this to then have this in its set of things to understand. Whereas we're reading it and we can kind of get some visuals, but we may not have. We're not might if you're I'm familiar with the topic, so I know what visuals I have, but your version of visuals I have, I don't know that either. So I'm going to move over to this frame back here. So there is a interesting thing. Masahiro Mori created the like in the late 70s, early 80s, the Uncanny Valley graph, and this was the idea about human likeness. And as you got closer to real, like a stuffed animal, people accept pretty well. Humanoid robot, but there are some like moments where a corpse, for instance, because that's a dead thing, or a zombie. These are things that shouldn't move that do, and they're mapped out in this uncanny valley just before like you get to a healthy person. So this is actually just a construct, and it's interesting because it was a reading, not a deep reading of Freud, but it was a kind of topical level reading of Freud, then mapped into we have moving and still as these things that kind of give us an idea of what could be scary, what's not scary, what's real or what's not real. And I would say you've got moving and you have still. And now we've done this, but we have the power of words. Some of the answers from things like ChatGPT come back as sort of not very real, like a hallucination. And some of them come back as spot on or even a connection that we might not have made. So this is sort of like we're kind of in a different place. I'll just show the classic problems are Polar Express, where you have motion capture, but it doesn't quite fit right, so everybody moves funny and just seems a little off. And sometimes it's like errors are simply in there. There's another one called from Mass Effect Andromeda where they did procedural eyes. So the eyes of the person started going all kinds of different directions while they were talking, and that actually took from the realism and then made it super creepy. So those are things that are more akin to the hallucinations that GPT would have. Is that it just has something that it instead of it being visual in our brain says this is off and uses that version of uncanny, we're reading it as words and we have to interpret that, and that comes off as uncanny. And I just want to point out when we're working online, what are our senses? So I'm saying the virtual robot engages in our virtual activities on the internet. So essentially, our personality online is mediated by all this technology, and that mediated technology is like the person we are, but it's kind of it's either the shadow of the person, or it's our person, or it's all of those different. But when people read our material online, that's perceived as real. So that's another factor in this. So it's starting to build what I would say that beautiful like new Canny Valley. So everything's on fire, but sure, it's fine. And just to point out, we also have such beautiful results. We have things that are mirages, things that are kind of the hallucinations, but we also have such beautiful results. So this is something that that we really how to say, you just kind of like we're telling ourselves a story about reality and how much of it we believe through our senses, right? But when we're reading gives us a different engagement for that. So anyway, that's kind of just a setup of like there's the Canny Valley, and the new technologies are kind of causing sometimes things to be more than real or more believable, and that's kind of an interesting problem. So I've set the stage for that. So I'm going to move to next area, which is we just need to do like a primer. We don't got time to get into too much of that, but we've got some time to talk about kind of the ingredients of ChatGPT and how we get to that point. And then later on, we actually have finally, but we're getting people competing with ChatGPT. So anyway, we'll get there a little bit, but let's talk a little bit the large language model. That's the other, it's like the top of the mountain without the base of the mountain. So I'm going to get to the base of the mountain before this is over. So we have GPT-3 and GPT-4. These are large language models from OpenAI, and they started with GPT-1, 2, 3. They kind of went through these progressions. And the idea is that it's a massive neural network that has what they say 175 billion parameters. The previous models have 10 billion parameters. We have new models with even more parameters. And what it means by parameters is that there's like little the particles of information that you can organize. Those little particles are then grouped and organized into like different levels of meaning. But having more of them allows you to take, say, the whole internet plus all the books and all of the things that it was trained on. So it really specifically has to be trained. So what it's trained on is Common Crawl. Yeah. Maka is pointing out GPT-4 is expected to have 100 trillion parameters. So this is the thing where, in order to do this stuff, you actually have to have large supercomputers, larger than say what Rutgers has. But Rutgers has big supercomputers. It's just that this is so enormous. So it's not everybody and every researcher can just grab it. And this is another element. OpenAI, it was an open company that's now sort of a not-for-profit company, but it's closed a lot of stuff. So it gives us previews. So I can say it has Common Crawl, it has Web Text 2, it's got Books 1, Books 2, Wikipedia. And this combination of information is basically broken into tokens, and the tokens are then fed into the large language model. Those parameters figure out all the relationships, and that kind of becomes the sum of knowledge. The other part is when you do training, there's a thing called an epoch, is one successful training pass through the entire data. So they have 0.4 epochs, 2.9 on web text. So web text is really weighted, but Wikipedia has been trained 3 times. So it's 3 times, it's almost as much as web text. So if we had, like, we know kind of what's in Wikipedia, we can look up what's in Common Crawl, but these are the old weights and things. The newer ones from ChatGPT 3.5 or GPT-4, you have to wait for the paper to get some of that information. But these are the keywords for it. But yeah, the idea of training multiple times on Wikipedia is actually weights the Wikipedia result more than, say, the books. And the other thing about books is like what book set are you reading? Modern novels, or are you reading all of the stuff that's non-copyrighted? And that kind of creates a situation where you've got translations from the past that are weighted because the translations of today aren't in the book collection. So that's one of the things people will be negotiating over, that book material to put into their massive large language models at some point. Just as a note, was GPT-3 and ChatGPT trained on its own API, and that's like its own programmer interface. And well, whatever was there in 2021, it was trained on. But all of the new stuff, you actually have to prompt it to sort of give it. Here's an example of the new code. So help me with new code on the new code that I gave you examples for. And then the idea of like, okay, we filled it full of this information. Well, does it really understand your topic? And understand is the key term. It's actually a predictive model for like next words. It's very fancy. So it actually not only finds a good next word, it finds a good next paragraph. So the chunking of this is pretty amazing. There's a couple other key terms that I want to make sure people kind of get caught onto, which is the idea is a large language model can do a lot of interesting things. So one is called zero shot. So zero shot is a type of training where you just simply ask the model a question, and if it's not in its known set of classifications or categories, it'll actually make a new category and answer you. And the accuracy of zero shot is a measurement of how good your model is. So this is one thing that GPT-3 and ChatGPT do really well on, because they're meta learner architectures. They are able to create categories on the fly so that it can handle the nuances by creating a new category to fill in the nuance. And that's with zero shot. You're just simply asking a question never seen before, and it's going to try to answer. Now, it will also get these wrong, and it does this more frequently. So this is one of those things where it does it um, by like essentially, I have no information, but I'm going to give you an answer because I'm compelled to. Essentially, it's got a prompt that says explain or summarize everything. So it's super like mansplainer essentially, because it's told to be a summarizer and an explainer bot, and that's so. At zero shot, it'll tell you something that it has competence in, but it won't tell you what it thinks has competence. It also won't show you the 3 or 4 or 5 or 10 different answers that it generated. It'll just show you the top one when you're using like a ChatGPT. Then there's another one called fine tuning. Fine tuning is sort of like, well, we recognize that there's a new data set that's never seen before. So I've got a company data set, and I've got a data set on like say the how students performed for 50 years at Rutgers University, and I want to like have an expert know about how did Rutgers students do. And we could anonymize it, we could do everything, we could screw it up and put people's names on it, but we could feed it an enormous data set by fine tuning it. And now it's an area expert around sort of whatever Rutgers student data we fed it. And now again, you got to be careful though, right? Because now you put student data in, did you put anonymize it, that kind of thing. But fine tuning is something that can make it an expert in a particular area that maybe it was weak in, it failed zero shot. So there's one called few shot, and this is also the power of these large language models, is that if I write a few examples of what I'm interested in, and then it picks it up, creates the categories, and responds in kind, I only have to give it a few examples, and now I have something new happening. I can give it a new idea, a new interpretation, but instead of like hundreds to thousands to millions of new data points, I only need to give it like 3 sentences. This few shot is essentially prompting it, feeding it, setting the stage. So these are the high level concepts. You're going to bump into this if you start digging in. I just want to make sure you saw those. Now, one of the ways that we need to that is really important is that vision is actually a really good clue to think about the large language model. And it's specifically because we can sort of say, how do we see the world as data? And this is really, really important. So vision is like we're all using a camera, and the pixels of the camera are coming through, and those pixels actually can be numerically represented, right? X, Y, Z, X and Y for 2D. So over here, I have like virtual vision, seeing the world as data. So I might have what's like an array of information that says, I have a white space, a black space, white space, black space, da, da, da. And when I look at this little symbol, I can say, is it a plus? Is it an X? So even in a little small shape like this, there's an equivocality of like, well, what's our interpretation? Is it X's or plus? Is it plus and an X? It's kind of so even in something that's just zeros and ones, we're in a situation of like, okay, that's interesting. Don't know how it goes, but you can see we can map a little number grid 101, 010. This is really fundamentally a pixel being on, pixel being off. And then you can rearrange them. So if I started at one corner and read through this sequentially, like I was reading a sentence, I could go 0 through 8 or 0 through 9 or 0. It's actually 1 through 9, but it's 0 through 8. So anyway, you can make it that thing. And so when you're looking at this sort of data, trying to say, is that a plus or an X? You have to memorize the sort of patterns that it might be. So this is sort of like every camera creating pixels is doing this, but instead of just black and white, it'll be full color. So you'll have like 16 million values for each of these entries of a pixel. So now we kind of have that numeric thing, but there's a fundamental building block. So instead of being at the top of the mountain, go to the bottom of the mountain and look at the dirt. What's it made out of? So all right, we've got the machine learning approach here is we're going to feed the senses. We're going to feed this information, and we're going to use something called the perceptron. Perceptron is the very minimal, basically, neuron that a neural network is built out of. And so a perceptron has inputs and an output, and it can have multiple inputs and outputs. But the one little circle that perceptron is the neuron, and it's activated through a function. So the shape of activation changes. So it might And that's a kind of a more detail oriented thing, but you can change the shape of the decision in the neuron. What will trigger it gets basically a wave. And is that wave like a sine wave or is it a straight line? So there's something that says, hey, that perceptron, and we don't have to get into that. So we're going to move it over to that. Okay, let's say I took those pictures and I created a set of pixels that are numbers. So I have 8, 7, 6, 5, 4, 3, 2, 1, and I've mapped this into a grid. And wherever the clear white section and the black section, I map that all into the pixel set, and it moves into what now looks like a series of dots that are all connected to each other. And this is kind of like the idea of I have a layer of neurons and I have a layer of neurons, and those neurons will connect to each other. So when those connect to each other, I can make associations. So one layer of neurons can simply be the full input of like, is there, is it empty? Is it full? Is it true? Is it false? And it just layers that up. And then I can have another one that maybe responds to the letter 8 has a piece of information that like, if it's in this zone, it might be an 8. So we train this multiple times to sort of decode the information out of it. So there's a convolutional neural network that's kind of the shape of this one is that the layers, then it has an output that gives you a number. Oh, it's an 8 and I'm 90% confident. But it could be a 7 and I'm, like 5% confident. So that's the sort of way down under the hood piece there. And I just want to relate this to the idea of steganography real quick. So people have may have run into this idea or not, but the idea is that we can embed information in the images. So in our case of like putting an 8 in there, we've embedded an 8. In the case of video and my hands and my face, I've embedded hands and face, but I can also embed the numbers and colors. And one of the steganography tricks is to write a bunch of colors across each other, and then you use a filter like a blue, green, or a red filter. And just those little changes start showing the information inside. So this is kind of like what we're doing is we're kind of finding a very fine-tuned way of organizing information from images, but we're kind of doing it the other way. We're finding the information in the images. Then finally, we have complicated neural networks. So I might have a number coming in, and I'm going to have a different architecture in here. It might have a lot of different rows. It might shrink down the data. It might expand the data, but it's now a complicated structure that maps all the little elements of where in that is a 3. What parts of it more likely activate 3s? So the neuron sets are all going to be kind of like creating their own layers. And that's where it gets like the black box idea is that we're creating our own layers, or not we're creating our own layers, but we're setting up the layers, we're feeding the information in, and it's optimizing its own connection from the input to the output. So the question asked and the answer given, there's a black box there that says, how do you explain that? Well, these models don't have the ability to explain unless you go looking inside the box or you redesign. You got to have another design to do that. So I want to just sort of get that piece out there. And this scales. So this is scaled to the part where we can recognize birds and horses and deer, and we can say it's 85% confident that it's a deer. Birds and frogs, etc., can all be these different things. So I also did a quick time check. So long story short, we can mess with the categories. And the other part is that we can get to the part where I've got a cat that has dogness or a dogness with a cat. You can actually hack into the human vision system and kind of try to figure out, well, what's going on here? Is this a dog or a cat? These things are happening in large language models, but time-limited humans don't necessarily get a chance to figure out if that's a dog or a cat. So anyway, and then the other, like, are these hamburgers real? Like, you have, are these people real, but are these hamburgers real? And the old generation technique creates some horrifying burgers. And the new techniques create some horrifying burgers, but also some super realistic and yummy ones. So anyway, I don't have time to get too far down, but we keep drilling down. But I want to I'm going to have to jump a few just to hit my time right. So supervised learning is examples from humans. Reinforcement learning is game-based learning. And generative adversarial network, like in our vision, is one network generates it, the other network criticizes it. So they go back and forth until the outcomes that we are looking for or we approve of or the data says is correct matches. And so a generative adversarial network is part of the ChatGPT project. So I'm going to run back over here. Of course, there's a model. So what they did was they took the large language model that generates all this text, generative pre-trained network. But what they did was they put a system of human supervision in place. And the idea with the human supervision is that we studied answers of like the model tells us this when I ask that question. So how do we make this more human? So they broke it down and they looked for basically outsource the idea of violence to somebody else to label all the violence, which is its own negative thing. And then they basically more or less like tried to evaluate human values so that the answers come back making sense to humans. So now you got hallucinatory information that is always going to be described in a making sense kind of way. So that's one of the crazy parts. The one concept that I want to make sure we've got is we've got the idea that we've got the ability to put words to numbers. So I would say images to numbers, words to numbers. So text as a vector. So bovine buddies say, and then there's a thing called a list of text, and it's all the properties. So these large language models have to map out those properties. And then finally, it does a thing of sentence prediction. So if the dog runs, there's a pathway through here. If the pathway, but what happens is they're all scored as to like, hey, it's 0.5, so this is a nice short one, but this valuable one is way over here. So how do you get to that valuable one? So this is a whole numbers game. And the numbers game is how do you make connections between the different concepts? So we go from the vectors to the concept. So I've got a, whoa. So I'm going to have to like take a look at I'm going to jump, of course. So power is encoding. So just this last part is that we've encoded all of the text. We break down the words and we map it to ideas. The ideas are kind of what's kind of the unit of measurement inside. The tokens are all of the words and pieces. So we have something that pays attention to different parts of images. Now we have things that pay attention to sentences. So sentences that are difficult to order and organize, basically in this model has that find the path and is a very smart find the path because it's more interested in the paragraph. So when you teach people to read one word at a time, you get into an issue of like, well, what is the meaning? Because I'm reading too small. So anyway, a couple of big hits is one of the reasons that math is so bad is that you can learn your numbers 0 through 9, or you can learn your numbers 1999, 2000, 2001. You have to learn math by reading it. And if you group your numbers together, 1, 2, 3, 58, 2001, 4, 5, 6, that's really going to mess you up in terms of like, well, how does my math work? So essentially, they're training it now on single digits, but then you lose out on grouping things like 1999 and 2000 together. Really important thing is your data sources. I've actually had text generators give me stuff from the Donald, which is like hate site. So that stuff is out there as a hugely difficult thing. Okay, so I gotta jump quick. So I'm gonna go back to screen share. So the ChatGPT part. So if I wanted to get into the language learning component of this business, is that you can create, like the idea is, I just want to get like your prompt, your tool. So let's make a game. I want to learn Spanish. Can you show me a random emoji? 3 words to choose from. One of those words is the correct. Prompt me an answer Spanish. Can you tell me if I get it wrong? And then it actually creates a game where you're answering questions in Spanish, manzana, and basically doing vocabulary learning. So that's that portion there. And I know that I want to do Q&A, so I got to stop. But I want to answer your questions as well. So let me run back to the Miro board because it has the rest of the info on it. So with that particular example, I can go to a new thing called nat.dev, and it's actually a comparison. So if I ask different language models how to play this game, it gives me an answer about the game. It says, sure, here we go, thumbs up emoji, and some sort of details. So essentially, we can use a multi-thing, and I have a link to this in the document. So I know I went through so much stuff. So essentially, the tools are really interesting. So you can do the prompting and all of that. But I wanted to make sure we got under the hood a little bit, um, and kind of got a sense that there's research down at the bottom, and that research really needs help. And like some of these language models will only do some of the things that you need it to do. Like this one doesn't play the game. ChatGPT plays the game. Others describe that you're trying to play a game, but we actually have a lot of different models to choose from. And I'm having trouble popping in and out between the two things without showing an infinite number of bricks. So the key part is that these language models have kind of got the recall piece, and you can ask it and prompt it, and it's going to recall information for you. The power of the words is really critical. And what it's doing is it's kind of creating this new space. Um, Yeah, thank you. So please, I guess the post-its won't plop in there. So if you guys can put into the chat any questions you have, because I wanted to make sure that you saw that it wasn't all, like that there's some tech down below and that you have to, you've got the situation where like in the one thing, like, hey, this is fine, but it's all on fire. So I didn't. And the other part is this is kind of a series. I've been doing study groups for 5 years, and I have like 5 years of material to draw, and then I'm just trying to jam in to about 40 minutes. So let's see. Yeah. So then the classic one is that is chat. So ChatGPT and academic integrity. I think one is that we have um, yeah. So how do we avoid those biases and new meanings? Okay. So one of them is that one of the things is to look at education upon the idea that we have, I'm going to move back over here, the hidden for now one. We have engagement. And the engagement portion is that we need to actually share our chat GPTs. The students need, like as the person pointed out in Big Blue Button, is that we need a tutor mode. And with a tutor mode, we can actually have the we can actually create the engagement we need. I can't make this show up. So the idea is that you share the results. You have to prompt a question. And I actually have a really nice setup over here called Chatting with GPT. Let me pop over to this real quick. Is that you're going to have the problem of the student engagement. So it's a send of attendance, you got engagement. And the element here is that if they can turn in their chat GPT, you can see the engagement they had with the material. And so here's an example that is really, really fun. So there's a prompt that I have, which is Blade Runner analysis. So I have a prompt that I'm a student in a course in science fiction. Can you explain this writing prompt? What does the professor want me to write? It says, write a paper on dehumanizing effects of the modern Ridley Scott's 1982 film Blade Runner. Consider the direct effects of medical technology who has access to healthcare. You may wish to consider income disparities, disenfranchisements, power gaps in film noir as expressions of modernity. You may want to consider the alienation from nature and isolation of the individual society. Be sure to use quotation and analysis. And here, I got the writing prompt is actually to write a paper about the ways in which modernity is portrayed as dehumanized Ridley Scott. And you can engage in the paper, but you got to share this. And then I can be like, what's an example of a paper where the instructor wants? And it says, well, they want something like the dehumanizing effect with an introduction, body paragraphs, income disparities, and it's like, if I turned in this example, what grade would I get? And it's like, well, you got to make sure to get a high grade. Here are the things you need to consider. And then I'm like, what percentage similarity is the example paper to what the prompt asked for? And it's like, as an AI language, I'm not able to provide that kind of thing. So we have quite the situation when it comes to like so trying to figure out these scores. But the deal is that we really need a social mode. We need a tutor mode. We need some kind of engagement mode that will make this happen. Sorry, guys. Anyway, I really, really appreciate you spending your time with me. And I have a lot more to offer in this space, and this is just the beginning. So that's really the thing, is that this sort of engagement. I think integrity comes from being able to show your work and being able to show your chat gpt, and the earnestness of which you did something is there. When you do things like ask for, give me what the instructor wants, it's better that it has a tutorial type mode. And in fact, that's what chat gpt can do now, is that I can embed chat gpt to anything. So that's the part, is that I can embed um, ChatGPT, and that's what you're going to see, is ChatGPT is going to be in every phone, every device. it's it's um it's going to be kind of crazy in terms of what that does, but it's a model designed to please you, and it's going to give you information like that. And in the final stages of everything, it's really, because it's made out of words, it's super powerful. And in the end, it's just going to make, a beautiful mirage for us all. So that's probably given my time. So I'll stop there, and if you have questions, let me know. Yeah, I have a question that says, for instructors who want to know more, how do you recommend they get started? I actually think that getting started by just putting your work into ChatGPT. What they've stopped training on people's input now, so it's okay to put your work in. So, so two things. So I would do, first prompt, put your work in. But as an instructor, I want my students to, is a good prompt. And then the other is seeing what responses come back defaulted and what responses come back after engagement. So being able to see those responses. And then the other part, people forget that after you give an answer, like give me a bio of a nurse, and it gives you a woman nurse or a man nurse, you can say, why did you pick a man for this example? And it will explain why it got that particular thing. So prompting is really critical. So that's the setting up your prompt, giving it, so like the few shot idea is like, tell it about your class. And then you can tell it about your class by putting the syllabus in and all of these different elements. And now you've got this interesting thing where you can say, as this assignment matching what my syllabus is saying, you can have all these interesting conversations that way. And then the other part is you can do a prompt for tutor mode. So I can say, I want you to be a tutor. But you can make your own prompt. And I know I kind of, the session's over, but I definitely, you can make your own prompt. Yeah, I love talking about all of these topics. This is, I wanted to do a tech talk and a topic talk, and it's pretty rough to get the things mixed together. But it's important to know what the base of these materials are. Yeah, I would definitely want to do TLT workshops with this. I've been building out a series, and trying to do the whole series in one session is like crazy. But I would love to work with people more, because the prompting and the stuff with like how you can make it be a tutor, how you can use living documentation, how chat with your syllabus, all these weird things um, are out there. Yeah, that's true. So one, because it's sort of like, I want to explain why there's mysteries down under the hood. So anyway, hey, thanks everyone. I'm gonna drop off. Again, I will keep talking, but we'll talk some more later.